Alright, so this is a complex question. We start off with the block that's up on a ramp. It slides down and transitions horizontally off of a cliff, becomes a projectile, and then hits the ground some distance later. So the question is taking us in steps to find what is the speed of the block when it leaves the track. So we're looking for the horizontal velocity. And then we'll end up using that in part 2 to find how far the block's going to go before it hits the ground. Part 3, we'll figure out, well, what's the final velocity of the block? Now, we're going to do this with energy. We will have to use a little bit of projectiles in here. That's unavoidable for part 2. But the first step we want to do is make sure we convert the mass. They give us the mass in grams, and we want to convert that to kilograms. Easy step, just divide by 1,000. So my mass originally was 448. That's going to go to 0.448. Okay, so initially the block is at rest. So it does say at rest. That means that the original kinetic energy is 0. So it starts off with no kinetic energy. But it does begin with some gravitational potential energy. And we can figure out how much gravitational potential energy by doing mass times gravity times that original height. Okay. Now let me go ahead and change my color to red. And I'm going to use this point right here where it's leaving the track. And I'm going to call that the kinetic energy in the middle and the gravitational potential energy in the middle. Okay, so the kinetic energy is going to have some kinetic energy in the middle. We don't know what it is right now, but it's not going to be equal to 0. And our gravitational potential energy, that is going to be mass times gravity times the height at the middle, or the height of that little cliff there. So let's go ahead and just label variables. This is the height at the middle, and I should have labeled this one. This is the height original. Okay. You know what, I want to change my equation over here. So since it's going to have kinetic energy, it's going to have some velocity. We're going to use that to find what the velocity is leaving, and that's what we're trying to find for part 1. So we're trying to find the velocity there. So this is the setup, this is what's going on, and now we start piecing it together. So the original potential energy at the beginning, that's going to be equal to the total energy that we have. That's what we start with, and that's all we have for the rest of this event. So in the middle, we have 2 different types of energy, but they still have to add up to that original energy. So this is equal to Km plus UGM. Now we're going to ultimately solve for that final velocity. So let's go ahead and expand our equation. So this is mgh0, and that's equal to 1/2 mass times velocity squared plus mass times gravity times h in the middle. Alright, let's get like terms on the same side. So mgh0, we're going to move the other mgh to the left side. To do that, we have to do subtraction, minus mghm, and that's going to be equal to the kinetic energy. We'll leave that on the right side, and we will ultimately solve for v over here on the right side. Alright, so you can imagine where this is going. I can go ahead and pull out the m and the g. So the m and g can come out of that part, and that leaves h naught. Actually, let me keep my color coordination. That way you know where we're pulling that number from. Minus hm. And that's going to be equal to the right side, 1/2 mass times velocity squared. So really quickly here, we can see that the mass on the left and the right side are the same. So the masses are going to reduce out. Let me go ahead and get rid of those. Masses go away. And to get v by itself, we need to get rid of the fractions. So we'll multiply both sides by 2. When we multiply the right side by 2, that fraction will go away, and we will be left with a 2 on the left side in front. So 2g, the difference in height, 2g times the difference in height is equal to velocity squared. And since we're solving for the velocity, this is a velocity in the middle as it leaves, that's the square root, parentheses, 2 times gravity, parentheses, the original height minus the height that it's leaving, the height in the middle. Close both sets of those, and from here we can plug in our numbers, get an answer. So velocity at the middle would be equal to square root, parentheses, 2 times gravity, we are using 9.8, times the original height, my original height is 3.8, minus 1.9, and then close our parentheses around both of those guys. So we put that in the calculator, and I will get a final velocity, or velocity leaving the cliff, as 6.102 meters per second. And that's what your answer should be similar to. Now for part 2, we want to know how far it's going to go. And from here, we're going to treat it like a projectile. So to figure out distance, that's dependent on 2 things. It's dependent on how fast it's going to go and how much time it's going to take to fall. So we're going to find time first. And we're going to use our kinematic equation, the d equals v naught t plus 1/2 at squared. We're going to manipulate that for the y-axis, and we're going to move around to solve for the time. And what's going to come out to is the square root of 2 times the height, and we're using the height in the middle, because that's the height that it's falling from at this point. That's when it's becoming a projectile. Yeah. Divided by gravity. So divided by 9.8. Close our parentheses. Oh. Divided by gravity. Alright, now let's expand it and plug in our actual numbers. So that's going to be 2 times the height divided by 9.8. Our height, well, my height, is 1.9. So when I solve for time, I'm going to get 0.622, and then my fourth number is going to round up to a 7. And that's in seconds. Not my answer yet. I'm trying to find distance. So the horizontal distance that it goes, which is delta x, that is equal to the horizontal velocity, which was the velocity we found in part 1. So that's Vm multiplied by our time. So my answer from part 1, I had 6.102, and I'm going to multiply that by my time from that I just calculated, and that's going to be 0.6227. So my answer for how far, my answer for delta x, will come out to 3.7997. So my fifth number is going to round up and it's going to carry the 9. So it's pretty much going to come out to 3.8. And remember, I like putting 4 numbers, so I'm still going to put the 2 numbers after the 8. And that's how far it's going to go in meters. Right exactly at 3.8 meters. That's my answer for part 2. Now for part 3, let's do a color change again. For part 3, we're trying to figure out the speed when it hits the ground. And there are 2 ways we can do this. We can delve back into doing it with kinematics, like what we would have done before, still treating it as a projectile. We know it's horizontal velocity. We would figure out the vertical velocity that it hits the ground with, and then we would have to do Pythagorean to get the absolute velocity. But that's a little bit of a mess, so I think it's easier just doing it with energy. So we know what type of energy it starts off with. At the beginning, at the very, very start, it only started off with gravitational potential energy at the beginning. And we knew that that was mass times gravity times the original height, way at the very, very beginning. At the very, very end of this event, it's going to end up hitting the ground with some final velocity. So right before it hits the ground, it's going to have only kinetic energy. It's going to have some final kinetic energy. And that's going to be equal to 1/2 the mass times the final velocity squared. So you can see doing this with energy is a lot faster and a lot easier. So my 2 energies are equal. I can set my 2 equations equal to each other. Mass is going to cancel out and simplify. And so what this will all boil down to, if I clean this up a little bit. So I'm going to get mgh0 is equal to 1/2 mv squared, and my masses will reduce out. Those go away. We're going to move the 2 over to the left-hand side. So this becomes 2gh0, and that means to get rid of the square, all I have to do is take the square root of both sides, and that will leave me just with v. V squared goes away. So from there, we just plug in our numbers. So square root of 2 times 9.8. Our original height was 3.8. And that's going to give us 8.630 meters per second for our final velocity, and that's our final answer. So we can see that that's a lot easier. It's less complicated than trying to do it using projectiles. So energy being scalar makes things easier. All right, there you go.